Okay, so we are continuing to discuss on floods, and last time we have seen something, and today as well we will see how India is situated in terms of flood, and what are the what makes India vulnerable, and so on and so forth. And probably this should give us a good what do you say? This should give us a good platform or base for which on which we should say why this topic is relevant, and what we should learn from this. Okay, so and then probably we'll discuss specifically on what are the measures taken specifically in terms of planning and so on and so forth. A little bit we will see today also, but I think with respect to case studies and so on and so forth, we'll see in the next class. For now, it is we'll continue to discuss on the vulnerability of India with respect to the floods. We have seen all this. We have seen in last class also, like how flood is relevant and how it is impacting the Indian subcontinent, and what is the status with respect to India when we compare with other developed nations, okay, and how are we placed and what we can do. And we have also seen flooding is not a new phenomenon, okay, it has been occurring, and from the recorded history there are a lot of things that has been documented. Still we face this kind of situation, and we have said there are certain natural events or natural phenomena that we need to understand, and there are certain things that we can have some control on. For example, it's urbanization, control in land use, regulated land use, and so on and so forth. Okay, so that can help in reducing the impact of the floods. And we have also seen specific examples like how it has been consistently we are exposed to floods, and I showed some examples of what we tried to do in Chennai as well. And we did discuss a little bit on are we keeping quiet, do we do something in this regard, or is it something which is not explicitly discussed also. Actually, if you see, the government is taking initiatives. We have seen some examples like we had national level policies and so on and so forth, both in terms of structural and non-structural measures that can be implemented by the state government and local authorities. Unfortunately, we have seen that some of it is not which is not being implemented, okay, and which is not actually percolating down to the lower stakeholders. And we have seen some examples like in case of dam safety, how what is the national level protocol and why states are not able to do it, okay, and what is the status as of now pertaining to one such example. And also we have seen the recommendations of having a what is a zone for the entire country, so that the flood maps can be prepared, and which is still not in a complete structure. And also we have seen that there is a consistent discussion on, apart from structural measures, there is a recommendation for taking up non-structural measures, so that the whatever idea that is implemented is actually accepted by the community and it is implemented. Okay, when we say non-structural measures, is primarily doing capacity building at community level, bringing people into the policy or decision making process. Okay, community should be get involved in whatever things that is done in the in flood mapping or flood prevention or mitigation measures. Okay, we had seen till here, and if you see India in a greater detail, very basic details, like for example, India is the 7th largest country in the world, and we know where it is situated and how it is, what is the physical characteristics of it, right? We have Indian Ocean, we have Arabian Sea and Bay of Bengal, and also we have Himalayan mountain. These are kind of a markers for I think in urban terminology, urban design terminology, probably you must have come across something called markers, right? What are markers? That defines, okay, which we can use this as a reference to define a specific location, right? So like that, we have a markers. Okay, we have markers which are very prominent, and that will have an impact on the entire setting itself. Not only from flooding, okay, we will see the same thing when we discuss about cyclone, when we discuss about earthquake as well. How these markers have an impact on flooding, cyclone, earthquake, so on and so forth. And if you go into details slightly, if we dig in further, some of the factors some of these factors aggravate the issue of flooding, okay, which includes from because of the varied topography, morphology, river system, and precipitation pattern across the country, have an impact on how much what is the kind of flood that we get, and how it has got an influence on the floods. Okay, most of these floods are caused by consistent rain and heavy downpour, and there was a study conducted. Okay, I'll also share this as one of the reading materials, where most of the things that I'm discussing now is taken from this particular paper, and this is also one of the references taken from that particular paper. Okay, this is a recent review paper on urban, not urban only, floods in India. Okay, so that is the major reading material that I am using for this particular topic. And in that study, what they have done is they have monitored the flood data from 1985 to 2018, and they have categorized how we get floods. What are the major reasons under which we can put the floods that we encounter in Indian subcontinent in under different aspects. So if you see, 21% of it is because of the heavy rain. Monsoon rain constitutes to 60% plus, and other reasons, other 18% is divided in the form of failure of dams, tropical cyclone, okay, and rain, excess rain that we receive, which is quite unusual than monsoon rains. So still, if you see, 60% of the flood is caused by the monsoon only, and that's how the historical data shows. And if you see the Indian context in the entire in perspective, among all the river basins in India, Ganges and Brahmaputra river basin experience the highest number of floods. Based on the nature of floods experienced, India has 4 major regions. Okay, this is based on the study conducted. The entire country can be divided into 4 regions. I was thinking of putting a map, but I forgot to do that. That will give a clear indication of how do we read this data set. Anyway, fine. Maybe after the class I will just share it in the WhatsApp for now. Okay, so what has been said here? Based on the nature of floods experienced, India has 4 major regions. Brahmaputra as one of the region, Northwest River region, Gangetic Plain, and Central India and Deccan region. Okay, so like I said, this study was conducted between 1985 to 2018, and you can see, in fact, we can divide this. We have Brahmaputra and Gangetic Plain as one of the regions. You can see that every year the number of events recorded is more than 4 and 5. Okay, so 3, 4, 5. So every year or every 5 years of the study, or I don't know how the data is classified. It is 85, 89, 90. Yeah, I think it's 5 years time period. So every 5 years you see which means every year there is one event. When one event across this particular more than one event across this time period. Okay, especially in Gangetic and Brahmaputra river basins. So number of events that you see is more than 5 in which means 5 events have been recorded only during the period, during this period. So just to make it simpler, so if you compare that with the other river basins, for example, like we are currently situated now, we have Godavari, Krishna and Kaveri. So here the number of floods that is recorded is slightly relatively lesser than what is recorded in the Gangetic Plain. So this is this means that these region, the habitation around and across these river basins will have more is experiencing more floods, and probably we have to come up with specific interventions for this. Okay, so in further discussions we will specifically see the Central India and Deccan region, and probably a little bit on Brahmaputra river regions as well. So a significant part of the region faces frequent earthquakes and landslides, which disturbs the natural regime of the river flow. Due to this phenomena, the region that are expected to be flood proof may not always be the same. So we are discussing flood, but suddenly there is a statement on earthquake as well. So earthquake and landslides as well. So if you remember in the first units we have seen, these are not independent event as such. So suppose if you are talking about earthquake, this may lead to landslides, this may lead to floods, this may lead to fire, so on and so forth, right? So these are interlinked. These disasters are interlinked, and as a result, if you remember, okay, we have very briefly seen the disaster-prone maps of India. We'll see in details about earthquake as well. That time we will discuss that earlier we had something called zone 1 as well. Zone 1, which means almost no earthquake can be experienced, or the impact of the earthquake will be almost nil. We had certain zones like this in the Indian subcontinent, but now in the revised plan that was adopted in 2015, we no longer have zone 1 uh, uh, in the map. We start with zone 2 only. Okay, zone 2. So which means, in fact, all the landmass in Indian subcontinent or in India is prone to earthquake, the severity is different, but we will experience earthquake throughout the country. That's how it has been revised based on the recent studies. And that will also, like I said, this will also have an impact on the floods as well. So as the name suggests, like we have seen, northwestern region is located in the northwestern part of India. Although the flood risk in this region is relatively less, the major problem arises from the inadequate surface drainage and water logging. So each region has some issue. Okay, each region faces or we face a different issues across the landmass. For example, let us say whatever case studies that we look at in the, let us say, the southern part of India, we can't apply the same thing in other parts of India. Or let's say the kind of let's say we are discussing something on Krishna river or Kaveri river or Godavari river, and then probably we have some mitigation measures, and can we apply that mitigation measures in Gangetic plain, Brahmaputra plain? The answer is no. We still need to modify that and then come out with specific idea, contextual ideas to address the issue. So that is what is being discussed here as well. We will continue to see how these things have an same urban flood, okay, but have a different issue. Okay, before we proceed further, actually we are discussing something very fundamental, which we all should not get confused. Here, see, we are discussing floods with respect to rivers, right? So there are certain floods, or there are floods. I think if you recall, under types of disaster, under floods, you will see there are there are something called riverine flood, river-based floods. There are certain floods are called coastal floods. There are certain floods called urban floods, right? So riverine flood is where the flood is primarily caused by the river, the excess flow of river, or the carrying capacity of the river is not been taken care, or it exceeds the carrying capacity. It should flow, the water in which it should flow. Okay, that is one type of flood that we should understand. The second one is coastal floods, okay, and the third one is urban floods. Urban flood is something which we will be discussing in detail, and now what are we discussing is river-based floods. Okay, so just to give an idea, how do we put all this into perspective? Okay, so the Ganga river region covers a majority of northern part of the country and a few states in the western part of the country as well. However, in the northern part is where we get primarily the severe floods. The drainage congestion due to heavy rainfall and river erosion due to mass sedimentation deposition are two primary drivers for severe floods in this particular region. So based on the study, there can be many reasons for the floods. Okay, here in the Gangetic plain, it is primarily because of the heavy rainfall, okay, excess rainfall that happens in the northeast eastern part of the country, and northwestern part of the country, and the water flows towards northeastern part of the country, and also because of the river erosion, okay, and sedimentation. So these are the three major reasons, primary reasons associated for excess floods in the Gangetic Plain. And what about the Indian, the Indian central part, or the Deccan region? The central India Deccan River region covers almost all the southern states. The region is identified by major coastal states which are prone to tidal flooding during the cyclones. So we have a different issue in the southern part of the country, where we have sea, okay, and we have tidal flood as coastal floods as another issue that we face here. Most of the rivers in this region have adequate river water carrying capacity within the natural banks, except except in the lower reaches and in the delta areas where the average bed slope is very flat. We will discuss about this. What do you mean by this? I have an image to show how the topography varies within the Indian. If you take a section across, let's say from western part of the country to the eastern part of the country, so this aggravates the flooding problem, as the river water does not easily drain into the sea because of the tidal intrusion. So what do you mean by that? In the northern part of the country, we said we get enough rain here, and the water has to reach from northwest to northeast, eastern part of the coast, and the primary reasons associated is, of course, because of the heavy rainfall that takes place, and also we said the flooding occurs because of the carrying capacity. The river exceeds the carrying capacity because of the excess rain, sedimentation. Okay, all these are some of the primary reasons associated with this kind the river-based floods in the northern part of the country. In the southern part of the country, although we have Western Ghats, I think I'll show the images. We get excess rain here, okay, and some of the water has to reach the coast. We have two-way pressure, okay. So one is the tidal wave that hits the seashore, and we have water that we get from the western and eastern Ghats, and the water has to reach the seashore. So, and there is a conflict, and this is also one of the reasons for excess flooding in terms of in the southern part of the country, and also the terrain. Okay, also the terrain, almost the land that we have in the southern coastal regions are almost flat lands. So, which means there is no natural gradients for water to reach the seashore. Okay, yeah. Central and Deccan region consists of lot of rivers: Narmada, Tapti, Mahanadi, Godavari, Krishna, Kaveri, and so on and so forth. And all these rivers carry high flood discharge generated by, again, heavy rainfall that we receive. However, the coastal flood risk is not most acute in this region. The coastal problems are severe in delta stretch, where we also have an impact on because of the tidal floods and cyclone. Most of the time, heavy rainfall in the upper catchment area adds substantial amount of water to be discharged from that particular river. Okay, the river channel slopes is higher in the upper regions, which increases the velocity of flow, but in the lower spread, okay, we have relatively flat lands that prevents water reaching to the seashore in a quick time. And what is the kind of issue that is faced here is the soil erosion is one of the major problem that we face here. And many of the studies, based on the studies, it has been observed that 65% of the river, Mahanadi river coastline is facing soil erosions. They also reported that by 2050, the soil erosion would be one of the major issues that will impact almost all the districts or sub-districts in the Mahanadi river region. Okay, and Bay of Bengal is also identified as epicenter of post and pre-monsoon tropical cyclones. Okay, so we will, in fact, we will be discussing this exclusively on how cyclones are found in Bay of Bengal and Arabian Sea, and how frequently this is found in the Bay of Bengal, and so on and so forth. And in fact, I think when we were discussing in the first unit, I said 3 out of 4 cyclones that is found in the Bay of Bengal, and why, and so on, why and how it translates into tropical cyclones and all. We will discuss that when we go to that particular unit. In the last decades, it has already faced an excess tropical cyclones, such as a number of cyclones in 2010, 11, 13, 2019, and so on and so forth, and it has caused a lot of damage in terms of property and the loss of life as well. Like I said, the flooding here we saw it is because probably of the heavy rain, and here also we have heavy rains, and here we said the excess flow of water, okay, because of heavy rain, and also because of these because of the sedimentation. It brings a lot of debris across, and as a result we have issues of flooding. Here also we have the similar issues, heavy rainfall and so on and so forth. In addition to that, we have conflicting directions in which water flows, okay, because sometimes because of the cyclone or the tidal waves, okay, the water is pushed into the inlands, and we have rains, and the water is pushed to the seashores. So and I also said, apart from this, one of the major reason of floods is because of the kind of terrain that we have. Shallow land, flat terrain, and existence of high population density in this delta region increases the susceptibility of flood damage during any event. The intensity of flood can be severe if the cyclone is accompanied by high floods. So this is one thing that we can quickly relate and see how things work. You can see the elevation, okay, the green part, okay. These are, we don't have higher terrains, okay. Maximum elevation that you will get to see is 250 meters in the entire coastal region, okay. At least here the depth is slightly smaller, but if you see the depth here, almost flat lands, okay. The entire south western part of the country is almost flat lands. That's why we don't have temperature variations as well, because of this terrain. I hope we all can relate, right? Every 100 meter increase in the altitude, or the elevation, okay, there's a reduction of 1 degree Celsius of temperature. Okay, that's a thumb rule. That's a thumb rule that we adapt. So every 100-meter increase, every 100 meters increase in the terrain, and there will be a reduction of 1 degree Celsius in temperature. So, but if you see this in the southern part of the country, we have almost flatlands to a large extent. Okay, and that is also one of the reasons why excess rainfall does not reaches the seashore as it should reach, and that will also cause floods. Okay, so all these are primarily related to the riverine floods or river-based floods. And apart from this, climate change is a significant factor that has added to severity of the floods in the region. And it is reported that between 1900 to 2015, there has been threefold increase in widespread extreme rainfall events in the region, which is attributed to the influctuations of monsoon, westerly wind, and due to increased warming of Arabian Sea. What are westerly winds? How the sea warming has got something to do with cyclones and rivers? Cyclones and heavy rainfall. These are something that we will discuss along with the cyclones. And other things, this phenomena results in heavy moisture transport from the sea and landmass, resulting in heavy rainfall for 2 to 3 days. Mahanadi River basin is known to be the worst sufferer of floods in the country because of the climate change. Several reports have highlighted the fact that intensity of flooding has increased in Mahanadi. And it is primarily related to the change in climate as well. And also there are other things. There are several reports that highlight that unengineered operation of major dams have resulted in flash floods. Okay, and there is a new word here. Okay, flash floods. I think I must have explained it. Otherwise, also, what is flash flood? For example, let's say we have this. Let's say the terrain, and we are supposed to let's say we are on an average we receive an annual rainfall of, let's say, 1000 or 1100 millimeters and so on and so forth, let's say, for this particular region. And suddenly, let's say, for example, this is annual 1100 or 1000 and an average. If you see the Indian regions, we can say 850 to 1100 millimeters of rainfall that we receive for almost all the parts of the city. And we are discussing what are flash floods. The rain that we are supposed to receive over a period of, let's say, 1 week or 1 month, we receive in, let's say, in less than 3 hours or 4 hours. Okay, or sometimes it continuous rain for 2 days or 3 days, so on and so forth. So, which are nothing but flash floods. Okay, so this is sudden increase, sudden downpour of rain. Okay, and that will result in floods. That's one thing. The second one is cloud burst as well. Okay, there will be. I think recently also we had. You must have seen in the newspapers. In the northwest, we had cloud burst, and there was excess rain. Huge damage it caused within a very short period of time. Okay, and also some of the floods can also be related to how we operate the structural measures, the structural interventions, mitigations that we have made in the city. whether we are operating in a correct way or not. This is also another thing that we should check. There's another documentary here on Hirakund Dam. Okay, and what happened during 1960s and 80s, and there was some event associated with this particular dam. Okay, so you can check this as well. I think in this particular unit there are two things that I said. There is one event that took place somewhere in this time period. Okay, more or less in the same time period. Okay, that we are seeing now. Okay, for both there is a well documented. There's a detailed documentary on what has happened that particular time, and probably you can see that, and how this mismanagement of or misoperating of this dam has caused severe floods as well. Okay, so till here what we have seen is, if you have to put it in a summary, floods can be divided in 2-3 ways. Okay, so one is riverine floods, the river based floods, and coastal tides or coastal tidal floods or coastal floods. Okay, where we face floods because of the tidal waves. And the third one is, let me put the fourth one also. The fourth one is urban floods that we will see from some time now. And third one, we can put all this flash floods in one category. Okay, this is primarily because of excess rainfall within a short period of time, maybe 3 hours or 4 hours, or maybe within one day we get rain which we should have got in, let's say, 1 month's time. Okay, or cloud burst and so on and so forth. So what kind of interventions that we can bring for floods which are in a which will have an impact on large scale. Okay, so we are not discussing in details about what kind of mitigations can be taken to prevent primarily the events that is taking at a very large scale. Okay, we will discuss mitigations measures taken at a building level or neighborhood level or slightly relatable scale, which as an architect we should know. Okay, apart from that, we also there are policy measures that is taken and so on and so forth. We have briefly discussed about it, but mitigation measures we will just stick to a smaller scale so that we can relate something and then see what can be done. Okay, so this is in general, in a broader term on the floods. Okay, there is another type of flood, the fourth type. Okay, which I was just trying to explain. Okay, so river based, coastal or tidal based flash floods. We have urban floods. Urban flood is the issue that we normally face, and in India, and sometimes we misunderstand this with other typologies of floods. Most of the floods that we face in India is on urban floods. Okay, primarily. For example, let's say the floods that we face in Mumbai, Chennai, on or all the cities, core cities, is primarily because of the urban floods. And although urban floods were not native to India as the rest of the world, it has manifested into a serious problem over the years. Okay, this is one of the it's a big statement actually. It says it was not we are not used to this kind of flooding. We are used to river based flooding. This is a natural event, that happens once in 10 years, 25 years, that we were used to. But urban floods are relatively, when we say relatively new, we are talking about a time frame of 100 years, 150 years. Okay, so it's a kind of a new phenomena that we face, that is primarily because of the rapid growth and unplanned urbanization that India has seen. Okay, and which has put the entire Indian subcontinent into the risk zone, and we get excess flooding in the cities. Recurrent flood incidences in Mumbai, Bangalore, Surat, Chennai are few of the examples that we can relate this to. Most of the cities are unplanned and have poor drainage infrastructure, which are highly susceptible to heavy rainfall events concentrated over a short period of time. Most often, it takes the form of flash floods and does not provide sufficient time for evacuation. That's why this becomes an issue that needs a lot of discussions, understanding, and so on and so forth. Because we have very less time to react, we have very less time to prepare ourselves, but the damage that will result as a result of the urban floods is very severe than the other forms of floods, because in other forms we have some time to react, and then probably we will prepare. In flash floods we don't have time at all. Like I said, it can happen in 3 to 4 hours of time itself. Okay, and what is the major reason for that is unplanned and poor drainage systems in the urban areas. I can relate to one of the case studies probably. For example, during my doctoral research work, I did the mapping for entire T Nagar part. It's a part of Chennai. I was trying to do three-dimensional city model for three-dimensional city models. My intention was, when we do assessment, let's say when we design buildings, what is the first thing we do? We try to sketch the building in 3 dimension, and we see how does it look, and how does it will, where do we keep our windows, and how it will have an impact on how the immediate surrounding has an impact on the building which I'm trying to design, and how do I counter this? If there is some issue, I don't get daylight, what do I do? I don't get natural ventilation, what do I do? So we look at things in 3D, and then we try to conceptualize, okay, this is how the building is going to look, and this is how the environmental issues that will have an impact on this particular building. Can we do the same thing for city? Yes, and if yes or no is the first question, and if yes, how do we do, and if no, why not? Okay, so if you see literatures, if you see the current work, lot of things, lot of research and lot of time has been spent on to understand city in 3 dimension. The same way how we look at the buildings in 3 dimension. Okay, so cities also we do have capacity to model that in 3D and visualize them in 3D. So one of my interests was also on a similar line on, okay, if we have to model, if we can model one building and visualize it, can we do that for part of city or a small neighborhood, and see what kind of assistance we can get through uh, 3D city models. So one of the thing that I came across is part of the Chennai was planned. Part of the study area which I took was Tinagar, and it was planned in 1960s and 70s. Okay, and it was planned as a residential neighborhood. Okay, and prior to that, before independence, that particular area was also demarcated for residential, low-rise residential areas, and the density of development were very less, and the infrastructure were light in terms of water supply, wastewater, and drainage were planned for low-rise development only. That was done by the Britishers. Okay, and in the 1960s, this layout was totally made as residential layout. Okay, let's say it was converted from low to medium intensity residential development. Okay, and the infrastructure was slightly or almost not improved, or slightly improved to cater the density. It was planned in 1960s and 70s. After that, the infrastructure remained same till date. Till date, things have not improved. I did this modeling in 2013-14. Okay, and as on date also I know how the city is performing, and there's no conscious effort to redo or improve the carrying capacity of the infrastructure of that particular city or particular layout. It was planned in 1970s. Okay, and the infrastructure, when I say infrastructure, let us say it is supposed to, let me put it in a simple way. Let's do that diagram in 3 ways. Let's say there were only 10 buildings, well, theoretical. Okay, there are 10 buildings that was planned during the Britishers' time. Okay, and it was very low residential development area. And during 1970s and 60s, it was planned as medium residential layout. Okay, and this is, let's say, we will discuss only about wastewater, or let's say drainage, urban drainage, and it was catering low-rise development. In 1960s, this was slightly improved, and the infrastructure that was laid by the Britishers were adapted with slight modification or improvement in the drainage network. Okay, but now this has gone into medium. There were only 10 houses, now there were 100 houses. Now in 2013, when I did the study, it has had 950 plus buildings in the same area that was planned only for 250 odd plots. Okay, the major issue is this infrastructure or the drainage network that is planned in 1970s remains same for 2013 also, and of course it is for today also. It is the same. It has not been improved. Okay, we are relying on the old carrying capacity of the drainage network or infrastructure network to take out the kind of pressure that we are trying to put here, okay, currently. So that's why many of our cities fail, because the carrying capacity of the infrastructure that we have is outdated. Okay, this was planned for something else 30 years back or 40 years back. We are still using the same infrastructure now, where we have in fact, if you see, if I have to give you the number, there was an increase of 250 percent, okay, built up, and 400 plus 400% increase in the density. Okay, so but the infrastructure remains same. So this is common issue across the urban areas, where which leads to the excess floods and more issues. Not only flood, other issues are there. We are now just discussing floods. Apart from this, the encroachment of waterways settlements, poor maintenance of usually blocked drainage system, highly dense urban agglomerations with impervious lands, improper flood zoning, ignorance of building codes in flood-prone regions are key reasons behind increasing severity of urban floods occurrence. Okay, so there are certain keywords here that probably we need to have some takeaway. Encroachment of waterways, okay, this we all know, and I think in the I think I have shown this in the Chennai case as well. It's not encroachment of waterways; it is encroachment of water bodies. Okay, so in 1970s, the footprint of the water body was this much, and when we did assessment in 2015, the footprint of the water body has shrunken to this. Okay, and as usual, we saw flood water till its natural boundary, and where we have built up and very haphazard development over there. Okay, so that's one thing: encroachment of waterways or water bodies and settlements. Poor maintenance of the drainage system. Okay, that's another thing. We don't increase the carrying capacity, or neither we keep the drainage in order. And I said last time also, we have to prepare the cities for this kind of events. Okay, every year. So let's say before monsoon, we have to clean up the rivers, river basins, streams, our drainage systems, so that in case of rain we don't have issues. That is also we fail to do, and that have an impact on the floods. Highly dense urban agglomerations. Okay, like I said, a layout which was planned for only 250 housing units now accommodates 1000 housing units. Okay, so this is, we are putting a lot of pressure on the land, okay, on the infrastructure and so on and so forth, and that will have an implications as well. And of course, impervious layers, because there's no room for water to percolate down. Okay, it has to only flow through the surfaces that we have created in the cities. And other things, not respecting the codes and so on and so forth, are all some of the issues that we will have, we face. Urban floods require equal attention as that of riverine flooding, since the economic and social impact of floods in urban region are quite higher because of the kind of impact it creates on the city. Okay, so we have been discussing this till now, and we are saying that this is also very relevant and very pertinent now, and we should first of all be able to differentiate what is riverine floods, and then what are riverine floods, and then how urban floods are different, and what kind of measures can be taken. And I was trying to call my PhD scholar. She is busy this week. Probably next week I'll see if she can come and talk. And she's trying to work on something like this, right? So we have water body, and we have, let's say, lower part of the water body, or let's say this is discharge point, and this is part of the city. And as per the natural terrain, water is accumulated here because of rain and flooding and so on and so forth, and there is natural waterways through which the excess water that it cannot retain will go to the smaller water bodies, or it will reach to this shore. In the studies, what she's trying to do is we are trying to map this, how this has been modified, whether it remains like this or we have modified something like this because we wanted to build something here. Okay, are we changing the terrain? Are we changing the directions of the waterways? And can we do that? And what was the impact of that on the development that we have? Okay, so she has done some case studies, probably in Bangalore. Let's see if we can get some time next week to discuss on that. It is known that floods are unpredictable, and that providing a complete protection against them and succeeding in controlling their incidence is always not possible, but we can minimize the impact that we are trying to create. Unfortunately, the enormous recurrent damages in terms of disruption of regular lives and the property indicate that current flood management system in India is not apt to provide necessary protection measures. Hence, it is necessary to shift towards a better management system where we can have a little better way of managing this particular issue. Okay, here again the focus is again driven to bringing community back into the loop. Okay, so not like a top-down approach where somebody sits in an office glass building and then dictates what to be done at the site. Okay, so that's the kind of issue that we face primarily now. If we bring the community into the loop and then work with the community to address this issue, probably we'll have better management plan. Hence, under such situation, it is necessary to shift from passive response that relies mainly on structural measures to non-structural measures. Okay, example, forecasting method, land use planning method, flood warning or flood plain mapping, and participatory planning. Okay, this is where community is brought into the picture. Okay, so here there are some examples for what are structural measures and what are non-structural measures. Okay, in structural measures it is very clear, right? We are doing something physical. Okay, we try to bring some physical entity to control floods. It can be in the form of check dams and dams or any other flood prevention physical method. Okay, physically we try to do something at the city scale. This is one. The second one I have been saying is on non-structural measures. Non-structural measures, so far I have been emphasizing only on the capacity building or let's say training the decision makers, increasing their skills, so on and so forth. That's one. Second one is the community's participation in all this decision making and so on and so forth. In addition to that, there are certain things that we can also do as an architect, and let's say tomorrow you are getting involved in urban design or city planning or so on and so forth. We can do something at a non-structural way as well. We can contribute in that way as well. So let me read this again. It says it is necessary to shift from passive response. Here passive response means the structural response. Okay, from structural response we should go to non-structural measures. One such measure is flood forecasting method. Okay, and this is precisely what my PhD scholar is trying to work on. How do we take this change in topography in modeling floods? Okay, so how this has contributed to floods, and how do we know that in which direction water will flow, what will happen if we get flooding today. Okay, so there are many tools are emerging, and there are a lot of work being done on forecasting floods. Okay, so there are I think, maybe, let's say, if you are somehow interested in doing further studies on disaster related stuff, this is one of the topic that can be studied actually. And there are advanced modeling tools and advanced modeling procedures and courses also on even on flood itself. Okay, you can do a lot of work on this aspect. Okay, forecasting is one, which means predicting. How do you predict in a scientifically how the spread will be, what will be the impact of it, and so on and so forth. Second one is the land use planning. Okay, where let's say tomorrow, if you are involved in a development of a particular neighborhood, okay, and you as a learned person, sensitized person on how do you address the issue of flood, you take certain conscious decision in the planning. Okay, maybe at the site level, or maybe in the planning document itself. Suppose if you are in a decision making organization where your role is to come out with land use plan for the city. Okay, and how we have to respect the natural terrain, the flow of water, what may aggravate the floods, so on and so forth, and how urban planning can come into picture in this case. Flood warning. Okay, there are specific things that is also been done, because like we said, we can't prevent disaster. Okay, we can't prevent it, but we can minimize the damage, right? So in minimizing the damage, we should, one of the thing that should be done is creating awareness, and in case of danger, warning has to be given, right? So I happen to be involved in one of such process. See, for example, let's say this is one of the map which talks about the sea level rise, and it will have what will be the impact on the terrain. It's a very figurative map only. We also prepared something called flood maps, right? Flood map. We also prepared something called evacuation maps. Okay, I'll show you with examples maybe when we discuss about case studies. These are maps prepared by the cities, and then it is given to the general public to know where they are situated, and in case of emergency, what should they be doing. Okay, so warning can be issued. Let's say the city, there are certain warning procedures also. We will see this in the cyclone topic. When warning is issued, what time, how much time is taken, when, for example, let's say there's a warning to be issued to the city, when this should be issued. Is it issued 24 hours before the actual event, or 48 hours, or 72 hours? There is a procedure in which the warning should also be issued. Okay, so we will discuss on that. Prior to that, this can also be related to the flood maps that we prepared. Okay, and in case of emergency situation, how do we read this map? Okay, how do we take some decisions using this map? Okay, so I have seen in France, when I was doing my master's program, they did one exercise to they prepared a flood risk map for that particular neighborhood, and they gave it to hundreds of people to read and then take a decision. Let's say if you are given a situation, your warning is given to you that there is going to be a flood, okay, and you have this map prepared, okay, flood risk map prepared, and you have access to it, and by reading this map, what will be your decision? How do you take your decisions? Okay, so there are many interesting observations that came out. For example, let us say the maps has to be read by someone who knows how to read the maps, someone who does not know what is a map. Okay, so for example, let us say even architects, I know for sure there is no subject called maps in architectural curriculum, right? But there is there's something called cartography. Probably you must have come across this word in +1 or +2, or even maybe in the 10th class, geography class. There's something called cartography, okay, and there is a way in which the maps are prepared. Okay, what is cartography? Cartography is nothing but the science of map making. Okay, there's a procedure for map making. So this map is to be read by a technical person, non-technical person, or layman who does not know anything at all. But all three have to make the same decision, right? In case of disaster, how do I leave this place? So that is the decision to be made by someone who is technically sound, technically not sound, and somebody who doesn't even know to read and write. So how these three can be clubbed and prepare a map in such a way that it is useful for everybody. Okay, so this is something which we can also get involved. We have a lot of ideas, probably that can also help in coming out with some kind of interventions like that. Floodplain mapping, okay, this is again where we can contribute, and we can identify which area will get inundated and how much time it will get inundated, how much time it will take for inundation, so on and so forth, so that we can prepare our cities and neighborhood accordingly. Okay, so in summary, we have structural measures, non-structural measures. Structural measures is very clear probably now. It's all physical interventions. Non-structural measures can include flood forecasting technique, land use planning, okay, warning systems, and mapping exercises that we do in addition to capacity building and community participation. All this will come under non-structural measures. The current focus is primarily on is developed on multi-target policies. It is suggested that flood management strategies can be aligned with flood risk, water resource management, and development and environmental protection. So what do you mean by that? There's a lot of keywords here again. Flood, again, it cannot be seen as an individual problem, and we cannot come out with some specific individual solution for it. It has to be read along with environment. It has to be read along with the kind of development that we do. It has to be read along with how do we manage our water resources, waste resources, land resources, so on and so forth. Okay, so that's why in the one of the works that my PhD scholar is working on, although she is trying to work on floods, urban floods, but we are working under a broader idea called water sensitive urban design. Water sensitive urban design. How do we come out with guidelines for water sensitive urban design, where the focus of water we are trying to discuss is on floods. Okay, how do we design a urban area which are sensitive to flood? Okay, that is the underlining objective with which we are trying to do something on that. Okay, And in doing so, in flood management, okay, there are certain things that we should keep in mind. One is accepting residual risk. What do you mean by that is, the flood control measures are designed for events of normal incidences, but there can always be a catastrophic flood, and there is no certainty that we will be able to control that or not. Okay, so this is why there is a need for accepting degree of protection can be assured by passive measures. See, when we do flood management, okay, so I think I have said in the beginning, in the earlier discussions also, we can't entirely rely on structural measures. We can say that, okay, this will help, this will prevent flood. Let's say we have installed some floodgates, okay, that will prevent a flood. Okay, so we can't totally rely on the structural measures. We have to have non-structural measures in place, and also we should accept that even after doing all this, there will be issues. Okay, because it's going to be a natural phenomena. We do not have total control on what happens in case of disaster. That's one thing. Moreover, to guarantee a continuously high level of protection by flood controls, huge investment is necessary for attempting both maintenance and so on. Some amount of residual risk can be accepted by structural measures to manage the economic loss. This risk can be reduced by binding non-structural measures along with structural measures, as they will enable higher degree of flood preparedness. So when we prepare something, when we prepare the city and so on for floods, one of the first thing that we should do is we should accept that even after structural and non-structural interventions in place, there will be issues. We will be exposed to higher risk, okay, because we don't know the intensity of disaster. Okay, so that means there is always an element of risk involved in even after we are prepared ourselves for a particular disaster, and especially not to rely entirely on the structural measures. Okay, that's one thing that we should keep in mind. A secure connection between structural and non-structural measures will ensure considerable risk reduction for present scenario and also assure flood-proof strategy in the future scenarios. That's first thing. Second thing is implementation of multiple measures. Okay, consideration of wide range of management measures to reduce flood probability and exposure is necessary for building a robust system. Because, like we said, it's not good enough to address a flood in one dimension. We have to look at the issue of flood in multi-dimension. Okay, and the ideas and mitigation should also be multi-dimensional in nature. And in doing so, what kind of measures we should implement? A scientific based approach for preliminary feasibility studies on assessing how flood will have an impact. Okay, and having a improved drainage system and a real-time flood forecasting scenario. Okay, these are some of the things, like I said, non-structural measures, but these are some of the things which a lot of studies has been done currently. Strict implementation of building codes, demarcation of flood zones. Okay, and probably here we can also come into picture, where if you are given a site and you know very well that this is going to be the recommendations of building codes, which is strictly follow it. Okay, not to compromise on these things. Third one, improvement of governance. Okay, and we have seen that even though we have a lot of technology and tools in place for doing scientific assessment of floods, if that doesn't reaches the decision maker, okay, the decision maker in the municipal office or district office and so on and so forth, okay, this will be a problem. Okay, and I said that professional development programs or a lot of funding is available to do capacity building for these kind of things. Okay, especially to improve the governance. And I have been saying this, in order to do this flood management in a more effective way, the participation of people and also all stakeholders is very, very essential, so that there is some kind of a commonalities in which we approach the problem. Otherwise, each stakeholder will work independently and there will be an issue on that. And that's one of the reasons, especially in the urban planning, this is one of the reasons we have a lot of issues. Because, for example, let's say city plan is developed by somebody, okay, planners do that. Transportation plan is done by a transportation planner, and we have water network, okay, drinking water supply is held done by a separate department. Wastewater management is done by a separate department, okay. Waste collection is done by a separate department. Environmental issues are done by a separate department. So these are independent organizations, they are doing something independently, okay. And if they don't sync, okay, if you don't have commonalities in all these stakeholders, we will have issues, not only in terms of floods, on all other related stuffs as well. A considerable dividend can be obtained within the urban regions as well as where the rate of urbanization is adding to the flood. In such regions, the newly identified concepts of sponge city, green roof, rainwater harvesting, segregation of rainwater from sewer system, regular cleaning of sewer system, and water infiltrations can also be some of the strategies that can be implemented. Okay, so these are some of the things which we directly do as architects, and let's say if you're given a chance to do something at urban scale also, we do read about and we do discuss about sponge cities. Okay, green roofs, of course we do discuss this at building level itself, right? So, and of course we do discuss this in the site plan and also at the building level. How do you incorporate this idea of rainwater harvesting in the buildings, in the city, in the site plan, so on and so forth. So, there is a mix of intervention that has to be done in order to make things workable in case of flood management. And the last one probably is on uncertainty in risk and its effective communication. The current forecasting system is limited to channel water level forecasting, which does not convey the actual risk that is there. Awareness of compounding risk to general public to enhance effectiveness of warning system. Development of easily understandable flood risk map for frequently inundated areas and so on and so forth. So warning, like we discussed, is also something which has to be integral part of flood management. Okay, and I was saying that we should have flood risk maps for the city, and that should tell us what to do in case of disasters and so on and so forth. For earthquake, we have some manuals like this that is prepared by the ministry, and it's kind of do's and don'ts during earthquake. Okay, we will see that the time. So like that, we need to have something called do's and don'ts during floods as well, that we have to have, and that will help in that will help in the management as well, management of floods as well. Okay, so with that I'll stop for the day. These are actually more of a theoretical approach on how India is doing to manage floods and what in general can be done to improve and manage the urban floods in specific, and riverine floods in other cases as well. And probably in the next class we will see examples of how mitigation measures are taken at city level and at the building level with the help of case studies, and also we'll try to read flood maps prepared for India, and we'll see what are flood lines. Okay, these are something that we need it when we do site selection, when we do site planning. Let's say if your site is closer to river or seashore, one question that is commonly asked is what is the flood line? Or probably, let's say if possible, we can quickly look at CRZ regulations, whether the CRZ regulation do speak about floods or not. Okay, so with examples we'll try to see in the next class. I'll stop here, and if there are any questions we are ready to take, or if you want to make some comments, please do so. Otherwise we will